Hello everyone, welcome back. This is Calculus 3. In this video, we are going to talk about 1.2, Calculus of Parametric Curves. So in the last video, we actually learned how to find out the parametric equation, parametric curve, with the given two x and y functions. So let's take a look at that concept here because today's topic is really relevant to 1.1. So here we go. So in this image, let's say I'm giving you guys a two function, x and y, and let's find out the parametric equation. So there are a couple methods you can utilize. You can use a substitution method. So one of the function is going to be sub into another function, or you can use a mathematical identity to simplify the given x and y function. Here we can say x equal to 2t plus 3 and y is equal to 3t minus 4. So I'm going to use a substitution method. We're going to solve for t. So x minus 3 equal to 2t. And then you're going to divide it by 2 on both sides. So x minus 3 divided by 2, that's going to be t. So now you're going to sub t, x minus 3 over 2 into the second function. So therefore, we found out y equal 3 times x minus 3 over 2 minus 4. I'm going to simplify this equation. So y is, use a distributive property, 3x minus 9 over 2 and minus 4. And then if you remember, we can separate those, fractions. So one is going to be 3x over 2 minus 9 over 2. And then 4 is the same as 8 over 2, correct? So therefore, you found out the parametric equation, 3x over 2 minus 17 over 2. So this is the parametric equation of this line, correct? Very good. So now, we are wondering, is there any simple, simple way we can find out this parametric equation? So yes, so 1.2, they are going to introduce the concept of differentiation, derivative of a parametric equation. So since this parametric equation came from those two functions, x and y, the idea is we are going to take the derivative of each x and y, and let's take a look at what we're going to get. So x prime of t, so you are going to take the differentiation with respect to t variable. So dx over dt, so 2t plus 3. In other words, we are going to take prime, so it is going to be t. It is going to be 2. So you know how to take the differentiation from calculus 1. So x prime is going to be 2 because we are taking the differentiation with respect to t variable. So we got 2. And let's observe what you're going to get y prime. So same thing, dy over dt. So we have a 3t minus 4. You will get 3, correct? And then let's see, y prime of t over x prime t from this observation. We got 2 over, actually 3 first, because the 3 is y, 3 over 2. So whoa. Did you see that? We found out here in the parametric equation, 3 over 2 was the slope. And then when you take the differentiation of each x and y prime over y2, we have a same slope, 3 over 2. So from this observation, we can find out the slope of a parametric equation. We can find the slope of parametric equation by taking derivatives. That's what we got from this observation. So this theory is actually going to develop to the next slide. I'm going to show you. So from this observation, many mathematicians developed this theory. You can find out the slope of the parametric equation by taking derivative, okay? So therefore, you're gonna take the derivative of the y function and x function in respect to t variable, and then that's going to be the slope of the parametric equation we just observed. Does it make sense to you? So let's take a look at the example. So this theory gonna help us to find out the parametric equation and more. And then it's going to be relevant to the critical points concept as well. So let me go to example 1. So here, I have two given function, x and y. They want you to take the derivative, each and x and y, with respect to t variable, and actually here they're looking for the critical points. Whoa. Did you guys remember what the critical point means in terms of the equation? So if you have, let's say, function up and down or keep going forever, critical points means it could be either local max, local mean, or absolute max or absolute mean. So at the critical points, so there are so many infinite points in this function, right? I'm just giving you guys example. Critical point means this one could be, local max, which is a little, maximum point, or it could be the minimum point. There's no more lower than this point. There's no more higher than this point. We call these are the critical points. So there are a couple of critical points in the function, right? So the critical points is very important and it's relevant to taking a derivative. So I'm going to think about it. So we're going to think about it here. The goal is to find out the critical points of this parametric equation, correct? So in this two function, they're going to create a parametric equation. There's gonna be a maximum or minimum point. First, let's find out the slope of the parametric equation first. Okay. So by taking dy over dx, in other words, dt. So you're going to take the derivative of the y and x. So what happened? I'm going to take the derivative. So 2t third minus 60, you're going to take the derivative. T second minus 4t, right? That's the y over x, y prime over x prime. So the first numerator will be 60, right? You're going to bring this one to the front. That's how you're taking the differentiation. T second minus t. And then we got the bottom one, 2t minus 4. So this is slope of parametric equation in the given two function. Now I'm looking for the critical points. So we're going to find out the critical points. So critical points, if you remember, it's relevant to the slope of the tangent line or slope of the given function. So critical points are the points at which you have a two case where numerator equal to 0 or denominator 0. We have a two case. So the numerator we know the 60 second minus 6. And denominator, we already got 2t minus 4. So we're going to say 60 second minus 6 equal to 0. And then I'm going to solve for t. So 60 second equal to 6. Cancel. T second is 1. So t is going to be plus minus 1. So at t equal to 1 and at t equal to -1, you're going to find out the critical points, okay? Another case you can think about it, denominator is equal to 0. And then that is 2t minus 4 equal to 0. So 2t equal to 4, t equal to 2. So what happened is, what that means is, critical points exist where numerator is equal to 0 or denominator is equal to 0. So therefore, so the numerator equal to 0 means the entire slope is a 0. And denominator 0 means entire slope is undefined. So let me write it that, because you want to know what that means again. So that means numerator is equal to 0, slope of parameter equation is equal to 0. That's what that means. Denominator is equal to 0 means slope of parametric equation is undefined. So we have two cases, if you remember, in calculus 2. This is how you're finding the critical points. So we found out three information: t equal to plus minus 1. At t equal to 2, at those 3 points, you're going to find out the critical points. So when we have a 3 case, t equal to positive 1, t equal to negative 1, t equal to 2, then what happened? You're going to find out the points at the moment. So we're going to plugging in into the function. So we have to find out x comma y when t equal to 1. So x function is a given. So x 1 squared minus 1 times 4. This is going to be negative 3. Y 1. 2 times 1 to the third. 6 times 1. This is going to be negative 4. So when t equal to 1, your critical points is going to be negative 3 comma negative 4. Hold up there. Same thing, the bottom one. Then x comma y, you're going to plugging in negative 1. So negative 1 second, 4 times negative 1, 2 times negative 1 to the third, 6 times negative 1. So you should get 5. You should get 4. Okay, we good. And then here is a 5 comma 4. And then the last one, we're going to find out the critical point. So when t equal to 2, so x equal to 2, 2 to the second, 4 times 2, that is going to be negative 4, y over 2, 2 times 2 second, third, minus 6 times 2, that would be positive 4. So we have negative 4 comma 4. So those are the critical points, okay? So if you imagine the graph, okay, negative 3 comma 4 right there, negative 3 comma right there. This is where t equal to 1. And then 5 comma 4, 1, 2, 3, 4, 5, 1, 2, 3, 4 here. This is t equal to negative 1. And then t equal to 2, negative 4. Negative 4 comma positive 4. 1, 2, 1, 2, 3, 4 here. Okay, so these are the critical points of these two x and y function. And then you can think about more, but I'm gonna just work on step by step. So this is your critical points, okay? So now you feel like you wanna do more. What does it mean exactly, right? So this is going to be, so this one we got negative 3 comma negative 4. When t equal to negative 1, we got 5 comma positive 4. This is negative 4. There's no other points above y equal to 4. There's no point. So this is your kind of like a local max point. There's no, they're same y because of same 4. So there's no point above y equal to 4. Does it make sense? And there's no points below negative 3 comma negative 4. So this is your local max. This is your local mean. This is exactly how we call critical points. Okay, critical points, you can find out local max, local mean. Okay, so that this is the graph we can imagine. If you want to find out more, we can graph it, but since this question is asking us to find out the critical point, that should be enough. Now, actually, we're going to do more and more example because I want to know what they mean, the t, critical points. So let's take a look at the following example. So here, what I show you here, the step is find out the slope of the parametric equation. By using this slope, you can find out the critical points where at numerator is equal to 0 and denominator equal to 0. So you're gonna find out the couple t. We have to find out 3 different t. And then this is a specific points where the local max and local min exist as a part of the critical points. Okay, so let's take a look at a couple more examples like that. I'm gonna go down here, example 2. So first one, we are looking for the critical points again. And the 2 function is a given. Let's find out the slope of the parametric equation. That's the given where you can find out the critical points. So d x prime of t, y prime of t. So this is a dx over dt. This is a dy over dt. You're taking y equation with respect to t variable. You're taking x equation with respect to t variable. So 2t minus 1 prime over t second minus 3 prime. So that's going to be 2. This is a 2t. We can cancel. So 1 over t, this is the slope of the parametric equation, correct? Now, here you have where numerator equal to 0, where denominator equal to 0, that's where you can find out the critical points. So here to find critical points, you're going to set up numerator equal to 0 or denominator is equal to 0. Already the numerator is 1, so 1 is not equal to 0, so we cannot do anything with the numerator, but the bottom, t. So t is going to be 0. So we have only 1 t, correct? So let's find out the point. So we have only one case, t equal to 0. So t equal to 0, then x comma y, you have x 0. So plugging in 0 second minus 3 is a negative 3. Y 0, 2 times 0 minus 1, that is negative 1. So when t equal to 0, we found out the critical points is a negative 3 comma negative 1. Okay. So what does it mean? If you graph it, negative 3 comma negative 1 here, right? And then we don't know exactly the graph, but here, this is going to be this is going to be either local mean and local max. Actually, I already graphed it for you. So what I'm saying is if you create a table, right? And then try to make a graph, you will actually get this one. This is the graph I found out. So here, when t equal to 1, you will get kind of like some points. And then when, t equal to negative 3 here, you will get the points here. So here we got actually here t equal to 0. What does it mean exactly? This is your critical points. There's no more points after, negative 3 comma negative 1. On the right side, on the left side, there's no point. So this is exactly critical points. It's not going continuously forever. They stop at the moment. Okay, so you can check it out. This question, actually this is a 4, my bad, and you can find out. So we have a negative 3 and 4, so you can plugging in 3 into this equation. You can plugging in 4. So this is a stop area. But these are not going to be the critical points because in this function, this point is the max. It's like a local max or local mean because there's no more points after this on the left side. So therefore the answer is when t equal to 0, negative 3 comma negative 1 is the critical points in this function. Does it make sense to you? Yeah. So think about it. Okay. It's not that crazy concept. It's an understandable topic. Okay. So let's take a look at one more. So that's why, derivative concept is coming, because it helps us to find out the slope of the parametric equation, so that it helps us to find out the critical points as well. So let's take a look at one more, letter B. So same type of question. I'm going to change the color. So we're going to take derivative x and y. So dx over dt, dy over dt. So t to the third, 3t plus 4 prime, 2t plus 1 prime. So that means 3t second minus 3 over 2. This is your slope of a parametric equation, correct? So we know we're going to find out the critical points from here. So critical points, you can find out where numerator is equal to 0 or denominator is equal to 0. So 3t second minus 3 equal to 0. And this is not exist. 2 is not going to be 0. So we have only this case. Let's solve for t. So 3t second equal to 3 divided by 3. T second 1. Ooh, we have a plus minus 1. So this is your t where critical points exist. So we have a two case when t equal to 1. I will say if, then x comma y, you're going to plugging in, right? So if we're plugging in x1, 1 to the third, 3 times 1 plus 4. What you're going to get? 1 minus 3 is negative 2 plus 4. So let me double check. Oh, I made a wrong equation. I'm going to plugging in x function. So 2 times 1 plus 1. That is a 3. And y of 1, 1 to the third, 3 times 1 plus 4. It's going to be 2. So it's when t equal to 1, you have critical points at 3, 2. Another case, if t equal to negative 1, then x comma y, x negative 1, 2 times 1 plus 1, I got negative 1. Y of negative 1, negative 1 to the third, minus 3 times negative 1, you should get 6. So what does it mean? It's going to be negative 1,6. So this is going to be your critical points, correct? This is your critical point. So let me graph it. So we have 1, 2, 3, 2 here. This is a 3, 2 when t equal to 1. And negative 1, 1, 2, 3, 1, 2, 3, 4, 5, 6 right there. So this is negative 6, t equal to negative 1. And then actually, if you create this equation, you're going to create a table and you're going to graph it, you will get this information. You will get this shape. Exactly. Or you can plugging in negative 2 and 2, the ending points. So x of 2, 5, x, y of 2, 8 minus 6 plus 4, 6. So 5 and 6. 5 and 6 somewhere here. So this is a t equal to 2. And then you can set, you can choose, you can find out more when x equal to negative 2. And x equal to y equal to negative, y of negative 2. And then it's going to be something here. Okay, you can evaluate it plugging in. So what I'm saying is, this is the kind of like graph you will get. My bad, this point is going to be a little bit higher. Actually, let's evaluate it. Negative 2, 2 times negative 2 plus 1, negative 4, 3. Negative 2, negative 8 plus 6 plus 4, we have 3. So 3, 2, same thing here. So when x equal to negative 2, it's the same 3, 2. So the graph is going to be something here. You see that? It's actually this. Okay. So therefore, what does it mean? we got exactly here, when t equal to -1, when t equal to 1, this is a local max and local mean. Okay, so this is exactly, you can find out the critical points when t equal to 1. This is the critical points of this function. Okay, so critical points is very important because you're going to use more. I will show you later, but this is how you are finding the critical points of the parametric equation. Okay. All right, so we can continue. Okay, now the next question is, the tangent line, right? Because if you take the derivative, it always relevant to the tangent line concept. So let me go down slowly. Okay, tangent line. So for your information, recall. What does it mean, tangent line? So if you remember in calculus 2 and 1, let's say we have a function f of x. I want to find out the tangent line at x equal to a. So what does it mean? Tangent line is touch the f of x very, very slightly. So this is your tangent line. So at that moment, their touch. This is the tangent line when x equal to a. Tangent line is always linear, y equal to mx plus b4. They're pointing one coordinate point when x equal to a. And then usually to find out the slope of the tangent line, you take the slope m, we took the derivative concept. By taking the derivative, we were able to find out the slope of the tangent line. So same thing we're going to apply here because we are dealing with the parametric equation. So let's take a look at the example. So that was a recall. Find the tangent line of the following parametric equation. So we have x, y function given. And then we're going to find out the tangent line when t equal to t equal to 2. I don't know. So in this equation, we can think about it. First of all, let's find out slope of tangent line. This is the same as slope of parametric equation. So we can take a look at the y prime of t, x prime of t, which means you're going to take the derivative y equation with respect to t, dx over dt. So 2t minus 1 prime over t second minus 3 prime. So 2 over 2t, boom, boom, 1 over t. So let me write it smaller. So prime, so we cancel. So 1 over t, this is the slope of the tangent line, right? Are you following? And you can actually graph it, okay? We can actually graph it. So if you take a look at it, t equal to -3, -2, -1, 0, 1. Let's say just 4, there's more, but we're going to find out x of t. So x equal to t second minus 3, y equal to t minus 1. So let's just fill out the table. So 9 minus 3 is a 6, 4 minus 3, 1. 1 minus 3 is -2, -3. I'm going to find out the last one, 16 minus 3, 13. And then for the y, -6, -7, -4, -5, -2, -3, 0, -1, last one, 8. So these are the coordinate points. And then let's graph it. Okay. So 6 comma all the way down here. And then 1 comma 5 here, something. I'm just approximately graph it. -2 comma -3. -3 comma -1. And then keep going. I can evaluate 1. 1 is a -2. And then we have 1 is going to be 1. So 2, -2, comma, +1. And the last one, when t equal to 4, 13 all the way down up here. So the graph is going to be something like that if you graph it. And then there's going to be points. So something like that. This is the graph. They stop there. They stop here. They stop here. Okay. Uh-oh. What I did, stop here and stop there. Okay. So this is t equal to -3. This is t equal to 4. And then we can find out when t equal to 2. So you can plug in 2. 2 is going to be 4 minus 3, 1. And then 2, 4 minus 1 and 3. So 1 and 3 is going to be something exactly in this line. So this is 1 and 3. This is t equal to 2. So what we are looking for the tangent line, isn't it? So let me minimize it. I'm looking for the tangent line when t equal to 2. This is the tangent line. They're only touch t equal to 2 right there. I'm looking for this green line. Am I correct? We already know the slope, right? And at t equal to 2, they're touching 1, 3. So we have all the information. So let me bring down, or actually let me make it smaller. So you have all the information. Tangent line is going to be y equal to mx plus b. We already know slope is 1 over 2. And then when t equal to 2, slope is going to be 1 over 2. Am I correct? So we have y equal to 1 over 2x plus b. That's a tangent line. And we just need to find out the slope. And then we know the points 1, 3 right there. So you're going to plug in 1 and 3. They're passing 1, 3. So you can find out b. So 3 equal to 1 over 2 plus b. 3 minus 1 over 2, that is b. So if you calculate it, 5 over 2, that is b. So therefore, the tangent line we're looking for, y equal to 1 over 2x plus 5 over 2. That's the tangent line. We just got this green. This is a tangent line. When t equal to 2, and they're passing through 1, 3, so that you can find out the slope b, and we already know the slope 1 over 2. This is a y-intercept, this is a slope. So that's how you're finding the y-intercept and slope for the tangent line of the parametric equation. Does it make sense to you? Yes? So this is a very, 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 popular question, finding tangent lines since calculus 1, 2, and 3. Just so your function is changing. We're dealing with the parametric equation. So that how you feel? Does it make sense to you? So this is how you do. I'm going to practice one more example like that. Are you ready, ready, ready? So let's go down slowly. Ooh, same question, same type of question. We are looking for the tangent line. So we have two parametric equation of x and y, and then they're looking for the tangent line here. So we know the story. This equation, these equation, they're gonna create, I don't know, you have to create a table and graph, but I'm just assuming something like that. They're gonna, let's say here, they have the parametric equation and graph look like that. And then when x t equal to -1, let's say this is a t equal to -1, they want to find out that tangent line. So we want to find out that y equal to mx plus b. So let's take a look at step-by-step work. So x prime over, actually y prime first. So y prime over x prime. So you will get t to the 4 prime over 2t to the 3rd plus 3 prime, that is a 4t third, 60 second, right? So what is it? This is slope of tangent line we're looking for. So specifically when t equal to -1, let's plugging in. So when t equal to -1, so that 4 -1 to the third, 6 -1 to the second. So -4 over +6. So which is, simplify, so slope of tangent at t equal to -1, we got m equal to -2/3, correct? Because I simplify. So good. Now, when t equal to -1, you can find out x comma y, right? So we're gonna find out that when t equal to -1, x coordinate points will be 2 times -1 to the third plus 3, so that would be +1. Y, when y equal to -1, -1 to the 4, +1. So when t equal to -1, they're passing through 1 comma 1. So we can complete the tangent line. This is that. So y equal to -2/3x plus b. And you're gonna plugging in 1 comma 1 into x, you can solve for b. So let's find out. Oh, I need a little bit of space. So therefore, so you're gonna plug in 1 and 1. 1 equal to -2/3 plus b. b will be 5/3. So you can adding +2/3 both of sides. So therefore, y equal to slope -2/3x plus 5/3. This is the tangent line when t equal to -1 of this parametric equation. Better, better, better. Okay? So you have a better confidence of what we are doing, correct? Let's take a look at a couple more examples to find out the tangent line of the parametric equation. Here we go. Okay, in this equation, parametric equation gonna be a horizontal or vertical line. So if you remember, recall. Okay, what does it mean, horizontal line? So this is the horizontal line. Yeah, and then it's always written by y equal to something. Okay, and then this is the horizontal line. And then if you have vertical line, is it passing through the x-axis? So x equal to something, that number is gonna be the vertical line. So for example, if you have y equal to 2, this is a horizontal line. And then x equal to -2, this is a vertical line, okay? And then when you have a horizontal line, slope is always a 0. For the horizontal line, vertical line, slope is undefined. So you remember from pre-calculus, calculus 1, so that's your recall. And let's look at the following question. They want you to find out the tangent line that is a horizontal and vertical line. Okay, so we good. That's your recall. So let's find out the slope of the tangent line first. So x, y prime t over x prime t. T to the third minus 3t prime over t to the third 3t second prime. So 3t second over 3t second minus 6t, correct? This is slope of the tangent line. Okay, so we have two cases. This is a slope of the tangent line. So you have, if 3t second is 0, the numerator is 0, right? So whatever 0 over some number is 0. So if numerator is a 0, slope, that means the slope is a 0. That's the case where you can find out horizontal line. Am I correct? Horizontal line. One more time. Numerator is equal to 0. So whatever 0 divided by number is a 0, right? We know that this is the slope of the tangent line. Slope 0 means what? That's where you can find out the horizontal line. Everything is a logical thinking, correct? Relevant to each other. If new denominator, 3 second minus 360, this is a denominator. If that is equal to 0, what does it mean? If you have whatever number divided by 0, this is undefined, correct? 2 divided by 0 is undefined. Million divided by 0 is undefined. So this is the case where you can find out the vertical line. Okay, one more time. Denominator 0, that means undefined. So that's where you can find out the vertical line, because from your long time ago memory, horizontal line is the slope is a 0. Vertical line means the slope is undefined. Therefore, you can set up 2 cases. All right, let's do the work. So what happened? Let's find out the t. So 3t second. Oh, I have a mistake here. When you take the derivative, it's a 3t squared, and we have still -3. My bad. So here, I'm gonna move -3 equal to 0. So same color. So that's a numerator. So 3t minus 3 equal to 0. When you take the derivative at y function, it's gonna be 3t second minus 3, correct? So let's find out the t. So 3t second equal to t cancel. T will be plus minus 1. So t equal to 1. I want to find out the xy. So x1, if you find out, 1 to the third minus 3 times 1, -2. y1, 1 minus 3, -2. -2, so let me minimize it. And then t equal to -1, x comma y, -1 to the third, minus 3 times -1, you will get -4. Y of 1, -1 plus 3, you will get 2. So we have 2 x and y when t equal to 1 and -1. So I'm going to just highlight that. That's our finding. When t equal to 1, these are your points. So one is -2, 2. This is -4, 2. Okay, we good. The next one. So these are the points where the tangent line is going to be the horizontal line. This is where tangent line is horizontal line. Okay, so let me minimize it. Second one, 3t second minus 6t equal to 0. I'm going to factor out 3t, t minus 2 equal to 0. So 3t equal to 0 or t minus 2 equal to 0. So t will be 0. And another one is t equal to 2. So we're going to find out t equal to 0, x0 is going to be 0, y0. You're going to plugging into this equation. It's also 0. T equal to positive 2, x of 2 equal to -4. Y of 2, you will get 2. So we have 0, 0, -4, 2. So these are the particular points where tangent line equal to vertical line. So what does it mean? Let's graph it. So I'm going to make a big graph. So here, let's point out -2, 2, -4, 2, 0, 0, -4, 2. So where is those points? -2, 2, -2, +2, right there. And then -4, +2 is here. 1 second, did I write down the correct point? So -2, -2, -2, so negative I'm missing. So let me redraw the points. So -2, -2 is right there. And -4, +2 is here. So this is -4, 2. This is -2, -2. So t equal to 1. This is a t equal to -1. Are we okay? Another point, we got 0, 0. Yeah. This is a t equal to 0. And t equal to 2, -4, 2. So -4, 2 is the same point. And then this is also t equal to 2. Okay. So what does it mean? Here, when t equal to 1, I'm going to highlight it. When t equal to -1 and t equal to +1, slope is going to be the horizontal line, right? So the graph, actually, if you fill out the table and later, if you have time, try. This is a very interesting shape. So it's going to be something. It is going to be this graph. Okay. So exactly, it makes sense. I will show you why. T equal to -1 and +1, we have a horizontal line. So they keep going. So let me graph it better. So they're going to be here. My bad. So they have to connect. So you see that here? We have a horizontal line. This is where y equal to 2, right? Because we are passing -4, 2. Here, this is the horizontal line. So the slope is a 0. At the same time, when t equal to 1, they're actually touch here, horizontal line. This is a y equal to -2. This is a horizontal line slope. Another one, we have a 2 vertical line. Here's another vertical line. Here's another vertical line. You see that? So when y equal to, so I'm going to write, when y equal to 2, this line, and y equal to -2, these are the horizontal line where when t equal to ±1, correct? And then when x equal to the vertical line, x equal to -4 and x equal to 0, this is the vertical line when t equal to 0 and +2, right? So that's your answer. So think about it. If you understand the concept of horizontal line and vertical line, that's going to be much, much, much better to understand this topic. So one more time, let me go up. We found out the slope of the tangent line. And then we found out the particular t when it is a horizontal and vertical line. So when you check the graph, exactly when t equal to ±1, we found out the vertical line at y equal to 2 and -2. When t equal to 0 and 2, you find out the vertical line at x equal to -4 and x equal to 0. So that's the solution. So think about it. Okay. So 1.2, we have a lot of concepts. So I have a part 1 and 2 video. So this is a part 1 video. So one more concept I want to just show you in 1.2. So far we are okay. We talked about how to find out the tangent line of the parametric equation. And then you can also think about more complicated problem like this. The next concept is a second derivative of the parametric equation. Okay. So I'm not going to really ask you what they mean here. I just want to show you how to find out the second derivative of the parametric equation. Okay. So just a little bit of information. So to prove it, I'm gonna actually make a more space. So let me get rid of it. So we are going to, I'm gonna just show you everything here. Okay, so I want to find out the second derivative of the parametric equation. How are we going to do it? You're going to literally take, derivative second time. So this is the second derivative, d second power y over dx second power. So I'm going to solve it, this one, to simplify the equation. So first of all, d second means d times y. And then dx second power means dx same thing. You're going to multiply twice. That's what that means. And then I can separate it. D times dy over dx times dx. I can extend it. So therefore, I can rewrite it. This one together, d over dx times this together, dy over dx. Okay. And then here, what we're going to do, dy over dx, this means the same as, so dy over dx, it's the same as dy over dt over dx over dt. So I'm going to substitute it. So d over dx, so this means dy over dt, dx over dt. Okay, so here a little bit of changing order. This number is getting involved with the numerator, so I can rewrite it d over dx times dy over dt. That's all numerator. These are all numerator now, and then divided by the denominator. Oopsie, I need a space. The denominator, we have dx over dt. Okay, so mathematically, what does it mean? This is, you are taking the derivative of the x variable, x function. So this is what the x function prime, and then this one, you take the y function derivative, and then you're going to take a one more time derivative in terms of the t. I think, yeah, we good, right? And then actually, for your better understanding, I'm going to change the order before actually we got. I'm going to show you one more time. I have a little bit of typo. So before we're going to get this one, so you don't need to memorize this one. Oopsie. So I'm going to just get rid of it. Oh, no. Okay. So before actually we got this part, I'm going to change the order. So this is xt prime. Let me change a little bit of order. So this is the same as d over dt and dy over dx. So this is actually y prime, correct? So therefore, d over dt, y derivative over x derivative. So this is what we're going to use at the end. Okay, so this is the formula of the second derivative of the parametric equation. So textbook, actually show you what the formula is. So you don't need to prove like what I did here. You don't need to worry about that. Just remember, I'm going to write it. Second derivative of the parametric equation, it's going to be, just remember the last one, d over dt. You're going to take the derivative of the y function first and take one more time of the derivative with respect to t divided by x function prime. That's it. That's all you need. This is a second derivative of the parametric equation. Okay, so let's take a look at the example. Exactly in this example, they are looking for the second derivative. So we're going to do step by step. So x of t is a t minus t second. Y function is a t minus t to the third, correct? So we are going to find out this part. So dy over dx, okay? So we're going to find out the dy over dx, which is this part, okay? So if you take the derivative, so dy over dx, so this is exactly this one. So if you're confused, let me just modify this equation a little bit. So I'm gonna just simplify this one. Okay, I already emphasized this, but let's use this formula because I don't want to use the complicated one. So what I'm saying is the last one, this one, you see that? This is the better one. So d over dt times dy over dx over xt. Okay, so this is the second derivative of the parametric equation. So let's take a look at it. So I'm going to find out this one, dy over dx, dy over dx. So what does it mean? This is y prime t over x prime t. So you will get y prime 1 minus 3t second over x prime 1 minus 2t. This is just dy over dx. Am I correct? And then you're going to multiply d over dt. So what does it mean? Here you are going to d over dt times 1 minus 3t second, 1 minus 2t. This is literally we're going to use quotient rule because this is a division. So the top is f and g. So if you remember, f prime g minus g prime of f, g second power. So according to the quotient rule, f is 1 minus 3t second, f prime is negative 6t, g is 1 minus 2t, g prime is negative 2. So therefore, d over dt, actually we already got dy over dx. What we are doing is f prime g, g prime f over g second power. Are you following? So I'm literally doing each step of the numerator. These are all the numerator work. These are all numerator. I'm doing this part, the numerator work. So we found out the dy over dx first, which is this, and you're taking the derivative one more time with respect to d over dt. And then now we are using the quotient rule. So the numerator, we're gonna get f prime negative 6t, and then g 1 minus 2t minus the g prime negative 2 f 1 minus 3t second over g second negative 2 to the second. Am I right? So g, oh, actually not the g prime. I use a g prime, sorry about that. So g was 1 minus 2t to the second. Okay, so let me simplify. Many distributive properties. So negative 6t plus 12t second. Double negative change to positive plus 2 and minus 60 second over 1 minus 2t to the second power. We can simplify. That is going to be combining like terms 60 second minus 60 plus 2 over 1 minus 2t to the second power. Okay, that's your numerator work. This is your numerator, d over dt, dx minus dy over dx. Now we're going to do denominator. Okay, what is it? Denominator, according to the formula, just x function derivative. So that would be what? We have already x function. D x prime t. What is it? That is going to be dx over dt. So the x function was t minus t second prime. So which is 1 minus 2t. That's it. That's a denominator. So therefore final, so the second, so I'm going to change the color, same color. Second derivative of the parametric equation, d over dt, dy over dx over x prime t, which is a dy over dt. So therefore, we have every information. This is a numerator. This is a denominator. So 6t second minus 6t plus 2 over 1 minus 2t second over 1 minus 2t. Right? That means 60 second minus 60 plus 2 over 1 minus 2t second power divided by 1 minus 2t, isn't it? Because this one divided by the bottom fraction. So that means we can keep changing flip over. Keep the first fraction. And then change the multiplication flip over, which means 1 minus 2t. So the final answer we got, second derivative of the parametric equation is 60 second minus 60 plus 2 over 1 minus 2t to the third power. That's your final answer. It's a little long work, but definitely we can handle it. Does it make sense? Okay. So think about it. This is how we are taking the second derivative of the parametric equation. We are following that example. The formula are actually given here. Okay, this is the formula. So we found out the numerator and denominator separately, and then you actually finalize the answer. I'm gonna do just one more example, okay, like this, how to take the derivative. Let's take a look at it. Okay, all right, so remember, write it, d second y over dx. Second derivative of the parametric equation, this is equal to what? D over dt times dy over dx over x prime. Same meaning, d over dt, dy over dx over, this means the x equation, you're going to take the derivative with the respect to t. So that's what we're going to do, correct? So step-by-step work. Let's find out this one first. So dy over dx. So we have x and y. So we're going to take the differentiation y equation. So that means y prime, the bottom is x prime. So this is going to be 2, the bottom is a 2t. Boom, boom, we have a 1 over t. In other words, t to the negative 1. Now we are going to take the derivative with the respect to t one more time. So d over dt, dy over dx we just got. So d over dt, we have a t to the negative 1. So you take the derivative. So t negative 1 divided by negative 2, right? So if you take the derivative with respect to 2, let's see. Did I calculate correctly? So let me double check. So t2, we are taking the derivative, t to the negative 1, so negative 1, negative 2. Yep, so that would be, we have t negative 2 over negative 2. Am I correct? Uh-oh, actually I made a mistake. This is not the derivative. I took the integral one more time. So you're gonna bring negative 1 to the front. So negative 1, t, and subtract the exponent. So negative t to the negative 2. This is the numerator. We finished the numerator work. Correct? Now, denominator, what is it? D over, you're gonna take the derivative x prime, dx over dt, which means t second minus 3 prime, so 2t. This is denominator. So the final answer, we got everything minus t to the negative 2 over 2t, correct? And I can flip over everything. This means negative 1 over t to the second, because negative exponent, you can change it to positive, divided by 2t. That means negative 1 over t to the second, flip. So the final answer will be negative 1 over 2t to the third. Got it. We got the second derivative of the parametric equation. So you're gonna please separate it, the denominator word and numerator word. Then you're gonna divide it by from numerator divided by denominator. Then you will get the second derivative of the parametric equation. That's it. And the following question, I'm just giving you the same type of question. Find out the tangent line and then try to, also take the, second derivative and try this one. Just practice question yourself, okay? So we finished half of information, almost done 1.2. It's a little bit of, more concept we need to go. So in the next video, I will finish 1.2. But please take a look at all the example we did today. You can practice by downloading my lecture note. And then if you go to 1.2 quiz, there are many embedded video. So you can watch to have a better concept as well. If you have any question, feel free to post in our discussion chapter 1. So me or our, your students, friends can help each other. That's where you're engaging with other people. Okay, so I will see you guys in the next video. We're going to finish 1.2 in the next video. This is a part 1 of 1.2. See you soon. Bye-bye.